Okay, now we're going to take a look at 8.3 compound interest, but we're going to focus on the present value. Okay, and what present value is, for example, you know how much you need to make in order to buy something maybe in 5 years from now or in 10 years from now. Maybe you want to save a certain amount of money in order to buy a car or in order to buy a house. Okay, and what we're going to do is we're going to say what present value, so what basically principal do I have to invest in order to kick out X amount of dollars in the future? Okay, so it's a little bit backwards. That's okay. If you understood 8.2, then 8.3 is going to be very easy. So suppose you want to invest some money so that you can make, so the amount that you actually kick out is 150,000 in 8 years. And where we see this a lot is like retirement. Like we know we want to retire with, say, $1 million. So how much do I have to invest now? Okay. And 8 years, let's go n equals 8. Okay. And you decide to invest in a savings bond that pays, so the interest rate is 0.075. Oh, 475. That's right. Okay. Compounded annually. So again, annually, you would multiply this by 1 so it doesn't change, and you would divide the interest rate by 1 so it actually doesn't change. But just to get into that habit, okay, when we see different kinds of compound periods, how much should you invest? So what we're actually trying to find, here's the principle. Now, I don't make anybody memorize another formula. What I do is I just take the actual formula that we've been using and I calculate it from there. Okay, so if we sub in the amount, say 150,000 equals, we don't know the P, but we know the I, so 1 plus 0.0475, and we know the amount of time, which is 8 years. Okay, so let's actually calculate this. And that's 1.0475 to the 8. Okay, so all we did here is add up 1 and 0.0475. We need the P by itself. We need the principal. What principal do I have to invest today in order to get this much money tomorrow? So 1.0475 to equal 8. So I'm going to divide both sides by this decimal, 1.0475 to the 8, so that those two cancel out. Therefore, we're going to get P to this, P equals something. In the calculator, 150,000 divided by 1.0475 to the exponent 8, I get 103,480. Remember, it's money, so it's 2 decimal places. Okay, so therefore, you must invest 103,480.62 today to have 150,000 in 8 years. Okay, example 2. Monica wants to start a business and needs to borrow some money. Okay, her bank will charge her 6.4%, so I equals 0.064, compounded quarterly. Okay, so that's divided by 4. Quarterly is, of course, 4 quarters in a dollar, so 4 quarters in a year. Monica wants to pay back the loan in 5 years. So I know our time is 5, but there's 4 compounding periods a year, so there's going to be 20 compounding periods. But doesn't want the amount she pays back to be more than $20,000. So we're going to max this out, the amount, at $20,000. What's the maximum amount she can borrow? So P equals question mark. And how much interest will she pay if she doesn't pay anything back until the end of the 5 years? So we want to know the amount of interest as well. Okay, so let's go. The amount equals P, 1 plus I to the n. Okay, so we know that the amount is going to be capped at $20,000. We don't know how much she's investing, but we know it's going to be 0.016 20 times. Okay, so this is simply 1.016 to the 20. And now let's divide both sides by that bracket. Okay, 1.016 to the 20, 1.016 to the 20. Okay, so if we put in our calculators 20,000 divided by 1.016 to the 20, we get 14,559.81. Okay, what does that mean? So therefore, the max she can borrow is $14,559.81, and then where she will pay. Now let's figure out the interest. So we know that she's going to have to pay $20,000. Let's subtract, go I equals 14,559.81. And how much interest does that make? 14,559.81. 5,440.19. So she's going to pay $5,440.19 in interest. And that's it.